This is a question from 2021 on circular measure. I'm just highlighting there some of the aspects we've been given. Make sure you change your calculator to radians from degrees. And so when we're looking at this question, it's very important that you set up the question initially. So the breakdown of the diagram, so to speak. I will be doing a number of diagrams today, and I'll be checking how these can be done in different ways. There's variations to how you can use the trigonometry here with this particular question. We were given PCS of 2 pi over 3, and from there we also know that a straight line is pi, as in the green dotted line, and we're given other details, so we know that the radius was 4, so half of that is 2 there, so sine 2 over 4, or 1/2, will be pi over 6, and so you'll get pi, which is 180 degrees. Just think we're doing this in radians. Pi minus pi over 6 minus pi over 6 is indeed the angle for PCS. Let's now look at a few other ways of how to break down this diagram. So we've just been looking at this first variation of using trigonometry, and we would have cut our circle in half and then use the sine opposite over hypotenuse to find it in that particular area of this diagram. But of course you could have done it in other ways, and I'm just going to show what the other two diagrams that you see to the right hand side, that you could do it that way too. So again, radius was 4, and if you think there's 2 radii there, so it's 8, so it would be the same idea if you're looking from the angle down below there of PCQ. And so you could have done it that way, or looking at an equilateral triangle on the very right hand side, and again you get a different angle of course of pi over 3, but again you could do it in that way and it would be the same result. Part B. Okay, now we're looking for the exact perimeter, so I'm just drawing out the 2 arcs on either side there. And of course we're looking for 2 of each, and I'll just rewrite that now. Redraw that little bit. And so we're looking for, details that we actually have at hand. We have our angles, we have our ideas about the radius and those parts of this question, and there's nothing much else. Just to keep in mind that a semicircle, like a straight line in a sense, would be pi, and so it's 2 times that angle times 4, plus, again, the green in this part, 2 times pi times 2. And you multiply that out and you will get your answer. That is 28 over 3 pi. And that's our exact perimeter. Now let's cut away again for part C, where we have to find the area of the plate. In this unit on circular measure, you often find the area of a sector. So if you look at our PQC part, there's a triangle and there's a segment above it, and so the whole sector is the triangle in segment. So what we're going to do here is we're going to find the area of the sector, which you're used to, and we're going to find the area of that triangle PQC, and we'll subtract them to get that little segment, that little part. So now we can have a look at part C and find the area of the plate. So there's our full circle. So 1/2 times 2 pi times radius squared. So that is equal to 16 pi. Then we have our 2 semicircle parts that were cut out of the plate, which is what the shape looks like now. So it's 1/2 times 2 pi times the radius of 2 squared. So that adds up to 4 pi. And then lastly, we have 2 segments. Now, first of all, we can't really find this, well, within this course anyway. So what are we going to do? Well, we're going to look at our sector. Now, I already explained this in a cutaway just previously, but we have a sector, and you're used to this. So it's a formula. It's like 1/2 times theta times radius squared. So our angle, theta, is pi over 3, and our radius is 4. That's for our sector. And you can do a little chop across there that I have for the segment. And so we're also going to find the area of the triangle. It's an equilateral triangle. Each side is 4, and we have that angle of pi over 3 as well. So half times pi over 3 times 4 squared is 8 over 3 pi. And then you have your triangle. Half times 4 times sine pi over 3. And so you end up with 4 root 3. Now we can subtract our segments and our smaller semicircles from the larger circle with center C.